Well, hello friends and followers. What do we have here? Well, this is a power amplifier, a PA assembly. The CB people call it a pallet or a 2-pill amplifier. They call these the pills. I guess they take a lot of pills. Anyway, so this thing is squirrely. I can't get any output through it on 160 meters, maybe a little bit. 80 kind of low, 40 and 20 work really well, 15 not so well, and 10 hardly at all. So I checked the driver on the Omni 6 Plus or Omni 6 over there. There's the Omni 6 over there. It's all kind of getting torn up because I'm trying to fix the transmit on it now. You can see where the brick in the back is gone. The brick is right here on the table. Anyway, I went through the the front end filter board and tuned it all up. You can tune up all these filter coils here. They kind of go like, they kind of start off, say like 160, and they go up to 10 meters here. So, and somebody broke one of those cores, unfortunately, on 10 meters for me. Anyway, back to the amplifier. So I was twiddling with the bias for the driver and the final, trying to make the bias change and adjust it per the recommendation of Tec, and I couldn't get the bias to move at all. And I thought, well, damn it all. That's probably one of the problems with this radio. So I took the PA amplifier off the radio and been snooping around in here. I think this IC here is toast. It's an op amp, and that basically is a comparator, and it's basically involved with comparing two values. So I'm most likely just going to chop this thing off, solder a socket in there. I'm not going to pull the whole board off the heatsink. There's no way I'm going to do that. So here's the schematic in the radio itself from Tec of the PA amplifier. I did verify that I have 5 volts here. That's working. So the reference voltage is working, and these potentiometers will use that. Well, will they? So transmit comes in here, and I verify them. This is ref voltage coming in here. About 9 volts comes in here. It makes 5 volts right there. Okay, yeah, and then this one will use that reference voltage to set the bias on the final. And that's the driver actually right there. So let's scoot this diagram over a bit. So yeah, so output 1 here, it'll drive this NPN if it goes positive, and this basically, let's see, this is going to, I think, VCC. Yeah, so they have a choke here, and then this is going to basically 13 in, and it'll get regulated here, and then that will apply a bias here to the bases of these transistors through this transformer. So that's how that works. And the driver is about the same. Actually, no, that's the driver. The final's over here. So yeah, the driver works that way. The final looks to be about exactly the same design, pretty much, with the transformer. So yeah, I suspect this chip is toast. I hope it's toast. I want to have something to fix here, not have frustration. So that's what I've been up to. I guess I can try a small demo here and show you what's going on. If I can get the camera positioned, we can work away at the demo. I think I'll use my coffee cup as a camera cradle and see how that works out. Turn it around. And we'll go like this. Okay, yeah, there, you can see the amplifier, sure. There it sits right there. Now, let's get down to business and check out some voltages here. That's probably more interesting than me talking, right? Of course it is. So the first thing we'll do is get a ground clip. I got voltage coming in. Just gonna ground this thing somewhere here. Let's see, how about over here? Slip it in like that. Don't touch that, that's hot. All right, there we go. And let's check voltage coming in. So first of all, there should be 5 volts on this ref here, I think. And click. Yep, there's 5 volts on that baby. See that there? So that's working. If you look at the amplifier on this chip here, the LM358, pins 3 and 2, pin number 2 is minus inverting pin, pin 3 is a positive pin. For the input, pin 3 comes right off the pot. So if you go count 1, 2, 3 here, and then you vary the pot, you'll see the voltage will change. And you're like, well, I can't see the meter. Okay. Okay, there's a ground. Let's move this ground somewhere else. Let's see, move it over to here. Okay. And we'll put the meter up here. There it is. It's hard to get it in the camera. Well, at any rate, can I even do this? Well, okay, there's the meter. The chip is here, pin 3. Okay, yeah, you'll see there's a voltage on there, and if I turn this pot here, can you see it in the camera? Barely. Anyway, you'll see that this will up and down. It'll change. Where am I line? There it is. So I can vary this up and down, and that will vary the comparator output and change the bias. So that one works. Pin 5 is the other pot. Pin 5 is right here. And you can see that that has voltage also. I'll turn the other pot. It's off camera, but watch. So anyway, that works. Now, what we care about really then is pin 1, which goes to this transistor here. And that's just been dead zero for me. No matter what I do, the chip has VCC going into it, as you can see. There's 13.8 volts going into it. There's the ground. So I think this chip is toast. I mean, who knows? It seems like it might be a little warm. But if I have positive voltage on the plus here, number 3, and I have negative on 2 or ground on 2, 2 should be well at ground here. Yeah, so pin 1 should be sporting some voltage here. So either this transistor is shorted to hell and back, or this chip is bad. It's one or the other. I checked this transistor and it's good. And this is the one I think that goes to the PA. Yeah, it's near the PA. So this transistor here, it comes off pin 7 on the op amp. So pin 7's right here. And it's just dead zero. So that's not too helpful, is it? Anyway, circuits 101, op amps 101, right? So whatever I do here, it doesn't make a difference. Pin 5. There's pin 5. That's the input from the little knob there. From the bias knob, the bias potentiometer. Pin 6 has nothing on it, right? Yeah, so this thing should be going up in voltage and feeding it to this NPN here. This NPN, let's see, that's got, okay, that must be the input. So that must be the, the collector, yeah. And the base, nothing, emitter, nothing. Oh, 13.8 there, okay, here, nothing, yeah. So I think once that's fixed, I'll have bias. So this thing's been working with zero bias, no positive bias. And perhaps that will make it not work with RF. I'm not that familiar with linear amplifiers to know, but my hope is I replace that chip and things get better. So that's my little lecture here. There's the circuit again that you can take a look at from the, and these are all pretty common to the Omni 5, Omni 6, the Paragon. I think they use the same PA pretty much in all these things. So you can download this stuff off the internet for the 10-Tec stuff. And I think even Bama has it. So that's it. Here's a little op amp here. Whoops, of course I hit the wrong button and it went to the wrong page. There it is. So basically what's going on with this thing. And that's it. So anyway, give you back part of your day. Thanks for watching the video and take care.